Rutherford alpha scattering experiment. Rutherford and his co-worker performed several experiments on the scattering of alpha particles due to the atom of thin gold foil. They take a source of alpha particle is a helium atom by He2 positive from which two electrons stand removed. Then the charge on alpha particle is plus 2e and mass of the alpha particle is nearly 4 times the mass of a proton. They take a source of alpha particle in a lead cavity, then here a beam of alpha particle emit, and this beam of light goes forward in straight lines with the help of this collimator, and in the path of beam of alpha particle, Rutherford place a gold foil, thin gold foil whose diameter is about 10 raised to power minus 8 meter, and around this gold foil Rutherford take a circular skin which is coated with zinc sulfate with the one side opening, and here this is a movable microscopes and it is work as a detector. Rutherford observed that when a beam of alpha particle fall on the gold foil, then the most of the alpha particle pass through this gold foil undeflected. When these alpha particles strike on the screen, a flashlight is appear, and the Rutherford observed this flashlight through movable microscope. He also observed that some of the alpha particle, about 0.14%, were deflected through a small angle less than 1 degree. A few of alpha particle, that is 1 in 8000, were deflected through a large angle may be greater than 90 degree. Some of them retrace the path, that is the angle of deflection is 180. Means when the alpha particle goes towards the gold foil, if there is a nucleus of the atoms of the gold foil comes in front of the alpha particle, because alpha particle and nucleus carry same charge, they can reflect back and retrace the path. When these alpha particle passes through this gold foil, fall on the circular screen coated with zinc sulfate, the short flashes of light are produced, and these flashes are absorbed through this movable detector. So this is the Rutherford observation. So we can write these observations in this way. First one, most of the alpha particle pass through the gold foil undeflected. Second one, some of the alpha particle, about 0.14% of the incident alpha particle, were deflected through small angle less than 1 degree. A few alpha particle, 1 in 8000, were deflected through large angle may be greater than 90. Fourth one, some of them retraced their path, that is the angle of deflection was 180. Fifth one, the number of alpha particle per unit area, that is n theta, that reached the screen at a scattering angle theta, were found as vary as n theta proportional to 1 over sine raised to power 4 theta by 2, and the graph would be in n theta and theta. N theta means the number of alpha particle per unit area, and theta be the scattering angle. So conclusion, these observations lead to the following conclusion. First one, as most of the alpha particle pass through the gold foil in undeflected, so it indicates that most of the space in an atom is empty. Second one, alpha particle being positively charged and having large mass as compared to the electron could only be deflected backward by some large repulsive force due to the heavy and positively charged region. So Rutherford concluded that the positive charge in an atom were concentrated in a very small region at the center of the atom. Rutherford named this heavy and positively charged region as nucleus. The alpha particle suffering large deflection would have passed close to the nucleus. Third one, the alpha particle which travels towards the nucleus directly get retarded due to the Coulomb force of repulsion between alpha particle and the nucleus and ultimately come to rest and then fly off in the opposite direction due to the repulsive force between alpha particle and the nucleus. Fourth one, electron being very light do not affect the motion of the alpha particle.